The second part of this Lunch and Learn, we will take a look at how to import jobs load tests into Azure ML and play around with it in the Azure ML Studio, which has a lot of nice tools for data munging and analysis. So let's take an example that we already have, so ignore what I'm doing right now. It's a lot of magic until I go and explain it. I just want to show you what we have currently and what we're going to change.
Avert your eyes, Gil. He said ignore this stuff.
So yeah, a bunch of stuff just happened, and we have these nice plots.
Okay.
This is the final output. We have build 101. So let's go ahead and grab some newer builds that we recently got and see how they compare to these things. So some newer builds we have is like build 107, for example. Let's go ahead and take a look at the time stat. So I have added this new step. I was testing it. It doesn't work yet. Save perf results, mainly because I'm not setting the right query strings yet. But I do have another one called an ad hoc that is working with the right query strings. So what we want to do is let's go and take a perf run that we already have and click on this step, the run cloud-based load test, and let's grab this start time information. So I have a query that will post all this information to a flow. What the flow does is it takes in the release ID, the definition name, the release name, and start time, environment name. Why? Well, the query it runs is Tony's query that looks up our perf data. It will take in the start time.
Not my query, but okay, continue.
Modified extensively.
Yeah.
That's pretty cool.
Yeah. Any questions so far? No? We just have to upper all the environment name. I noticed that was a little quirky. So we query for, we trim off the last and first 15 minutes of the data. We bin it by 5 minutes. And then we take each bin, eventually we'll multiply each bin by 12 to get an hourly bin instead of a 5-minute bin.
The heck? You... Oh, okay. I see. You could also, I think, use the Kusto tool or whatever.
I was gonna say, I think there's a equals like ignore case.
There is actually, I think, yeah.
Yeah, see?
Might be faster.
Awesome.
But actually doing a string manipulation like an ignore case might be easier to do a two upper, and then you see it have to pay the cost once as opposed to ignore case. If you want every comparison, would have to do them. Anyway, that's not the point of this function learn is Kusto optimizations on string comparisons.
And then we take the value of that output, the row set, and iterate over the rows, and we insert it into a blob. So where's this blob? And not blob, table. So where's this table? This table lives out in
Azure.
Come on, Jesus. Our dev account subscription. And under storage accounts, we have this jobs load report. Under that, we have a table called load test. And the schema is pretty simple. We just concatenate the release ID definition and the release version, I guess. The row key is just the 5-minute bins. This is just the import time. And then we just take the count of the 5-minute bins. And then let's go back to our flow.
I got 9 pieces of sushi.
Oh, neat.
Lucky.
We'll analyze that some other time.
To get
8. All right, so we have the release ID, definition name, release name concatenated, precise timestamp, bin, 5-minute bin as the row key, and the count as the count. And so I have a postman query where I have done this exact thing. So let's go ahead and ingest this new build into our system. So we'll change the definition name to be the official one. Copy this build version. Yeah.
And for those playing along at home, this was the one that fired this morning that said, or last night that said, it was 10 messages an hour was the 95%, correct? Like picturing what a distribution of jobs over those 2 hours would be to be bad enough for to do 95% is 10 jobs an hour. So let's see what that graph looks like to find out. Hopefully we did more than 20 jobs over those 2 hours.
Yes. I guess it was accepted. Let's go ahead and take a look at our flow. Hey, it succeeded 17 seconds ago. Let's go ahead and take a look at our data. See if it shows up. Hey, there it is. Oh, that's some pretty bad outliers there. Let's take a look. So let's now jump into the Azure ML world. So how do you go about doing that? So in Azure Portal, I think we can all create an Azure ML account. I'm not going to go into that, but you can go ahead and search for resources and go and create that. Once you do, though, the experience once you log in looks like this. Go to our My Experience experiment. And you can create some experiments. Let's go and take a look at one I've already created, jobs load test.
So just for a second, for back in the Kusto flow ingestion thing, you did multiply by 12 or you did?
I have not yet.
Okay.
And we will see that soon. So
is Jupyter and Azure ML Studio done in parallel, or is that one come after the other and they're like all a pipeline?
both. It's up to you. It's very flexible. It can be part of a pipeline. In this case, I added the Jupyter Notebook as the output of this convert CSV step.
Okay.
So it is part of this pipeline. But you can also do ad hoc Jupyter scripts independent of this tool.
Okay.
Yeah. So we have this step here that imports data, and you can see it takes from Azure table, put our input there. And then to play around with Jupyter Notebooks, you first have to convert that data to CSV. And then you can go and open the new notebook as a Python or R. And then, so I have already done that, and let's go ahead and run this.
Oh, I thought you were going to be saying, and then you have a violin plot. Like, I think.
So what is it doing behind the scenes? Let's go over this notebook and take a look. The notebook first imports the data from that experiment. This is just experiment metadata. And then we do, this is in R, by the way, so some R syntax here. We take a look at the data and summarize it. So take the first 6 rows, summarize the structure of the data.
Jupyter is part of Azure ML, okay.
It's open source actually, and this is just Azure ML's implementation of it.
Okay.
They're hosting it.
So for all the scripts you wrote them, or do you have some like example function you can call?
Yeah, I wrote these scripts, so you can look at these as examples.
So including the converting to like CS.
So these guys are out-of-box steps over here. Oh, there's so many.
All right.
And yeah, you just kind of connect them like Legos.
Okay.
Yep. And here, Tony, we do the 12.
Okay. Is there, out of curiosity, why did you, at this step, choose to, as opposed to like earlier?
Yeah.
Just out of curiosity.
I just wanted the raw data, just so I had more flexibility downstream to do manipulations on it, rather than having to.
Makes sense.
And then we'll just do some sanity checks. We do find the P5 hourly throughput. Here is interesting. There's different ways to calculate percentile. If you use their default, it actually tries to interpolate between 2 data points. Whereas if you type 1, it uses the actual data point.
Really?
Yeah. There's actually 12 different algorithms.
That's an interesting definition of a percentile.
It's really a question of how many data points you have. If you have, 200,000 data points, you can just find the one that's like 95th and do it. But if you have like 6 data points and you want 99th percentile.
Yeah. I thought percentile was just a more
Guessing.
precise version of, like, for example, median, which kind of always returns a point in the data set. So, like, returning something that's, like, somewhere along the line. Yeah.
I mean, but the thing is with that, so say you have 5 data points and you want the 99th percentile, which data point would you return?
Kusto by default uses the data point. Kusto does not interpolate.
I think even number of samples takes the average of the middle two.
Oh, yeah, exactly.
So yeah, there's different algorithms. And FYI, Kusto uses
Yeah,
type 1 of R's algorithm, and it does not interpolate. And then we do a sanity check, take one of the releases and just make sure we're getting good numbers. 5% matches it up with. Good, continuing. Now we're getting to some plotting. So we do some cleanup so that our plots are ordered by release ID. So here we clean up all that data so that the rows have some meaningful names. Here I was trying to be clever and try to add the sum information, the total throughput over the 2 hours on the same plot, but we know that's a little bit confusing.
That's the red dot.
Yes. And yeah, so here, what did we do? We used a library called ggplot2 to create these plots. And this library scales helps us just format the plot a little bit better.
Those lightsabers and spaceships are actually violins?
Yes. So let's create them a little bit bigger. Let's do a 20 by maybe 16 run. So what I just did is just increase the plot size. Here's the actual ggplot information group by hourly data, or use the hourly data group by release. This is the actual y-axis. Use the violin plot, overlay a box plot, relabel the axes, and just some more formatting stuff. But let's see if we have the new information yet. Ew, that's so small. Let me rerun all of this, run all, so that we get the new data.
In this notebook here, all of these all these lines are all mini scripts.
Yep, go for it.
Okay.
And do they build on top of each other if you define something in the previous script? So you have like a couple scripts to define different phases. Okay.
And oh, there we see the latest results of our 107 release. We see it's more of a lightsaber rather than a spaceship. We would like more spaceships. So how do you interpret these plots?
Should be a spaceship and it should be higher.
basically. We have the box plots, and as with box plots, the thick black line is the median, upper quartile, lower quartile range, and then the whisker shows us our outliers. And then the violin part of it is these wavy lines. What those show is basically a histogram on its side. So take a histogram, flip it on the side, and this shows the distribution.
And then duplicates it also just to
just to make it symmetrical.
Just to make it more suggestive.
Yeah, I was gonna say to emphasize the look of genitalia.
Well, you can't call it a violin, right? Unless it is. And so we usually want some more normally distributed data and grouped around the median. But whereas some of our newer releases, we see it's more very long tail distribution, and yeah.
So out of curiosity, in the idea of dashboarding and KPIs and boiling this down to a single number, so you can quantify week over week kind of thing, for violin plot and box and whisker, would a standard deviation, in your mind, summarize this? So that you're not comparing, last week's violin plot to this week's violin plot. While it is definitely meaningful to general analysis, but to track, are we getting better or are we getting worse? Do you think a standard deviation on these bins?
So here's what I think. If I just show this, it may not mean much to you guys. I can also show the standard deviation and variance on this, right? Basically, this is just summary data. What I think is I'll show this in addition to the plot, so that you can grok the data visually. Additionally, I want to compare it to maybe the last 3 runs and do a p-value kind of hypothesis test on the data to see, is it really different than the previous runs? Mm-hmm. And the p-value would be kind of saying, is a metric to measure, is it different from previous runs? I would want to say the summary data and the statistic would kind of show us, was it a good run or not? So maybe 2 of those. Thoughts? Questions? That's it for my demos, folks. I will follow up with some more detailed notes how you can do this on your own.
Did you want to do a quick go back to the graph with all the volume plots, and since you kind of got cut short at show and tell, just like interpretation of so this most recent data compared to the previous ones of why did we get a 10 jobs an hour P95?
Oh,
Like when you see this, what are the things
that
you're thinking about of like what should we go check? Like what looks weird on this? Like how do you interpret this into wow, were we getting throttled a lot?
Yeah.
Kind of thing. I'm just like take it just one step further.
If I have something to show.
Elbow didn't look ready. He looked. I'm giving him some time. He's getting his stuff ready. So
Sure.
we're buying him time.
Sure. So I'll give a little peek at a tool I use in Power BI to query our Custo data.
Yes.
So when I see that, I usually take a look at what was the total dispatch, and we see the total dispatch is actually pretty much lower than previously. It was like around 800,000, 900,000. I also take a look at the event summary to see what are the distribution of events or errors that we're getting, and what are the components receiving those errors. The 2s, the reds stands out. So that can give you insight into where to dig deeper. We see to take a look at the queue health, and over multiple runs, we don't always drain the queue entirely, so the queue depth is pretty unhealthy. We look at the dispatch health over time, and we see those same storage exceptions, server busy exceptions. So obviously we're getting throttled quite a bit, mostly on our table accesses. Yes. And then we can take a look at throughput, ingress, egress. But I think the major thing here is what are the errors and which components to dig in deeper. And that's where I would start the investigation.